Now let's calculate an empirical formula from percentage by mass. Let's take a compound that has carbon, hydrogen, and oxygen. If we submit that compound to combustion, burning it in excess oxygen, we end up with carbon dioxide and water. From a given mass of our compound, we can determine the masses of product and from those we can go back and get percentage of each element. Now let's suppose we've undertaken that operation and we have found a compound of this kind which contains 40.0% carbon, 6.71% hydrogen, and 53.3% oxygen. If we summarize those, add them all up, equals 100%. How do we turn this mass percentage information into an empirical formula? I suggest that you use a method which is very straightforward, which you can expand to include any compound for which you need to calculate an empirical formula from mass information, and which works. Set up a table. First of all, we put the percentage by mass, and remember, that means that is the same thing as the grams per 100 grams. We start looking at each element in turn. Carbon, hydrogen, oxygen. The percentage by mass, which is also the grams per 100 grams, is 40.0 for carbon, 6.71 for hydrogen, 53.3 for oxygen. We then turn these grams per 100 grams into moles of each element per 100 grams. Moles per 100 grams of the original compound. How do we do that? We simply take the mass and divide it by the molar mass of the element. So 40 grams of carbon is how many moles of carbon? It's 40.0 grams of carbon divided by 12.01 grams per mole of carbon. And if we calculate that, we find that makes 3.33. .71 grams of hydrogen is 6.71 grams of hydrogen divided by 1.008 grams per mole of hydrogen, and that equals 6.66. There's beginning to be an interesting comparison between these two, which is obvious at first sight, though it wasn't at all obvious from the percentages. 53.3 grams of oxygen, again turning it in moles, divided by 16.00 grams per mole of oxygen equals 3.33. We now reduce these to the simplest integral ratio by dividing by the smallest number. Because we want to get integers. Remember, molecules contain integral numbers of atoms, not fractional numbers of atoms. So we divide all these then by 3.33, which is the smallest. And the result of that operation is 1 to 2 to 1. Therefore, the empirical formula of this compound is C1H2O1, but conventionally we drop the 1 if we only have a single atom present. It is indeed one of the class of compounds we mentioned on the earlier slide, but we don't know whether it's formaldehyde, CH2O, or glucose, C6H12O6. It could be either one of those. For determining which it is, we need molecular mass information or molar mass information. So this could be or C2H4O2 or etc., including C6H12O6.